Ignition sequence start.
Good morning. Welcome to Mission Control Houston. This is the International Space Station Flight Control Room, where there's always a team of specialists on duty to monitor the space station systems and help the Expedition 58 crew members as they work through their assignments for the day. Commander Oleg Kononenko and flight engineers Anne McLean and David St. Jacques have spent time each day this week working on a variety of science experiments. But just a few minutes ago, they finished monitoring the departure of a cargo ship, which will perform more science as it finishes its mission.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Gary Jordan. This week, a cargo spacecraft is set to begin its secondary mission before dumping 5,500 pounds of trash. Northrop Grumman's Cygnus vehicle departed the station on Friday. Before its fiery demise in the atmosphere over the Pacific Ocean, Cygnus will alter its orbit a few times to deploy several types of satellites from different deployers. The Slingshot deployer will release some student and commercial satellites, while the NanoRacks deployer will release the KickSat-2, which will deploy 100 much smaller satellites called femtosatellites, weighing less than 3.5 ounces each. Cygnus is scheduled to re-enter the Earth's atmosphere in late February to conclude its mission in space. Canadian Space Agency astronaut David St. Jacques took a spin at an experiment that looks at fluid behavior. The Fluidics experiment is designed to look at a few aspects on how liquid moves in microgravity. The hardware consists of some transparent spheres and a centrifuge, specially designed to look at wave turbulence and liquid sloshing. Understanding how these phenomena are different in a microgravity environment could lead to better fuel systems for satellites, and even aid in improving climate predictions and renewable energy on Earth. NASA and its commercial crew program providers, Boeing and SpaceX, set new target launch dates for their upcoming uncrewed test flights. We're now targeting March 2nd for the first launch of SpaceX's Crew Dragon on its uncrewed Demo 1 test flight. Boeing's uncrewed orbital flight test is being targeted for launch no earlier than April. You can find out more and keep up with all the progress over nasa.gov/commercial-crew. This week's question comes from Nicole at RJO Intermediate School. She asks, how do astronauts breathe in a spaceship? Great question, Nicole. NASA astronaut Anne McLean was asked the same thing this week by elementary school students in El Dorado Hills, California, during a live event with the space station. We'll let her take this one.
The engineers on the ground have done an amazing job of creating this space that feels a lot like Earth. So other than floating, our temperatures and our air is almost exactly like we have on Earth. And that's actually because in order to live, we need certain things in our air, like oxygen.
Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
As Gary mentioned, the first test flight of the SpaceX Crew Dragon to the International Space Station is now targeted March 2nd. That's just 3 weeks from tomorrow. SpaceX and Boeing are working closely with NASA to get their vehicles ready for these flights. First, without crew members on board, and then the first flights carrying astronauts as they open up a new avenue for delivering men and women to the space station. while those commercial spaceships join the fleet, bringing crew members to the International Space Station, NASA's still pressing ahead with development of the hardware that'll be needed to take astronauts into deep space down the road. Here's a breakdown of the elements that'll support NASA's plans for moving out beyond low Earth orbit.
So you want to go to Mars. How do we send humans to deep space? In order for humans to explore the Moon, Mars, and beyond, we need safe, flexible, and powerful systems that will make it all possible. We start with the world's largest spaceport. At Kennedy Space Center, we have all the buildings and tools needed to assemble and launch space vehicles, and have the teams in place to recover the astronauts when they come home to Earth. Next up, we need a deep space rocket. This is NASA's Space Launch System. It will be the most powerful rocket NASA has ever built, and it has the muscle to lift people and all of the equipment needed for missions to new worlds. The Space Launch System will blast off with the crew in the Orion spacecraft. The most advanced spacecraft ever built for human exploration, Orion provides the life support, power, communications, and other systems to safely transport astronauts on a variety of exploration missions, like to the Moon. In lunar orbit, we will learn to live and work in a deep space environment, something we have never done before. In future missions, NASA's Gateway will be a place for astronauts to live, work, and prepare for missions deeper into the solar system. There you have it. NASA's Deep Space Exploration Systems, charting our new future in space. To find out more about deep space exploration, visit this NASA website.
Now, while that work continues, NASA is still focused on the mission of the International Space Station. Its location 250 miles above the Earth makes it a terrific location for scientific research about the planet. This one right here. Last year, an instrument was delivered which gathers information about how plants on Earth sweat. That provides data to scientists who are monitoring the health of Earth's vegetation.
Sweating can be cool. Presented by Science at NASA. Did you ever notice how the air can seem cooler when you enter a forest? Humans aren't the only living things that sweat to cool off. When trees and plants sweat, they cool themselves and can cool the surrounding air. Through a process called transpiration, water and nutrients are taken up by plant roots from soil and delivered to the stem and leaves as part of photosynthesis. Some of the water drawn up through the roots exits the plants through pores or stomata in its leaves, hence the sweating. As this sweat evaporates, heat is removed from the air, providing a cooling effect. However, if there isn't enough water available or relative humidity gets too high, the stomata close. The plant heats up, ceases to grow, and can eventually die. Healthy plants provide a number of ecosystem services to humans, including food, recreation, and building materials. Plants also impact Earth's global water and carbon cycles, with plant transpiration accounting for around 10% of the moisture in our atmosphere. A new NASA mission called EcoStress, short for Ecosystem Spaceborne Thermal Radiometer Experiment on Space Station, was successfully launched to the International Space Station on June 29, 2018. EcoStress will literally study how plants sweat, providing the most detailed measurements of plant temperatures available from space and helping researchers monitor the health of Earth's vegetation. Your temperature is one of the first things a doctor wants to know when you go for a checkup, says Simon Hook, EcoStress principal investigator from NASA's Jet Propulsion Laboratory. It tells your doctor a lot about your condition. Temperature is an extremely useful indicator for plants too. Temperature data can indicate if a plant is stressed and needs more water before the plant collapses, providing an early warning of a possible drought, explains Hook. EcoStress will be able to measure plant temperatures and therefore plant health over areas as small as an individual field of crops. The International Space Station is well suited for the EcoStress mission. Hook says, most Earth-observing satellites are in a sun-synchronous orbit, so they pass over an area at the same time each day. providing us a daily snapshot of that area. Because of the space station's orbit, EcoStress sees the same spot on Earth every few days at different times of day, so it can track changes throughout a typical day. If, during a hot, dry afternoon, plants stop releasing water to conserve supplies, EcoStress will see a change in temperature compared with previous measurements of the same area. It will detect these kinds of responses in farmers' fields and other ecosystems. Data acquired from EcoStress may, in time, help farmers develop crop watering protocols, give researchers a clearer understanding of the effects of drought, and assist water resource managers in planning effective water use. Its data could also reveal the effects of droughts on natural vegetation. For example, to help identify vulnerable types of trees. Forest managers and ecologists will be able to use this information to make better informed decisions. But that's not all. EcoStress temperature data will be useful in a whole host of ways, says Hook. We'll be able to use the same techniques developed to extract plant temperature to look at other phenomena such as the temperature of volcanoes, urban heat waves, wildfires, coastal currents, lakes, and more. That's a whole story in itself. Want to learn more about this cool mission? No sweat. Just visit science.nasa.gov.
Along with hosting experiments that are looking to learn more about Earth, the International Space Station is home to technology experiments to help humans get ready to explore out beyond Earth in the years to come. Recently, that's included a test of technology that might make refueling of space vehicles and satellites in orbit a routine thing. As we travel farther out into space, clever solutions to other problems like engine part malfunctions will be vital to NASA's preparations. 3D printing is an emerging technology that may be used to create custom mission-critical parts. But first we have to understand how the particles' shape and size and distribution affect the manufacturing process. One particular study is helping explore those factors.
One of the things they're going to have to do for space exploration is do additive manufacturing, because we may have an engine part that fails, and you're certainly not going to take up spare engine parts. You're going to have to manufacture them there. And a lot of what we want to do with that means looking at microscopic particles, because they're building blocks. And now I think a big part of the future in this field, and for lots of different reasons, is active materials. So now we have ways that instead of just the particles being just particles, we can activate them, we can functionalize them, we can get them to associate with one another specifically. So one of the things we're aiming for is active self-replication, evolution in microgravity, to put lots of things together and to optimize properties using evolutionary processes from not living things, but mimicking what living things have done so successfully. We'll learn how to do that on Earth eventually. But before we do that, it's much better, because they have different densities, to do it in microgravity. It's always really important to do something at the forefront of science that will then become a forefront in engineering and production.
The laboratories on the International Space Station provide a setting for scientists to do experiments that take the force of gravity out of the equation. And of course, these are experiments that they cannot do on Earth. For example, there is an experiment underway that's studying the sediments of quartz and clay and focusing on the forces between the particles that cluster together. In addition to being the hands-on laboratory assistants for science research in space, the International Space Station's crew members use some of their time to share the experience and help students learn about scientific concepts. Last year, astronaut Scott Tingle released this demonstration video about the importance of nutrition for men and women who are of this planet, if not on it at the moment.
Hello, and welcome to the International Space Station. My name is Scott Tingle. Here on the space station, we live in a microgravity environment, which makes eating here a very unique experience. To stay healthy, we have to maintain a nutritious diet, just like we would back on Earth. Let's go take a look at some of our food and drinks and check out our meal preparation area. During long-duration spaceflight, we have to make sure that we receive enough energy, proteins, and vitamins. Our food lab back on Earth makes sure we get plenty of each as they carefully prepare, test, and package everything. We combine all of this excellent nutrition with exercise to ensure our bodies stay healthy and strong while we're here. We eat 3 square meals a day, just like we do on Earth, and maybe throw in a snack or two. One of my most favorite foods to eat are natural raisins. Here on Space Station, we have to keep our calories up if we want to get all our work done. And the carbohydrates in these raisins really help. And they're kind of fun to eat, too. How do we stay hydrated in microgravity? With these special pouches. They're filled with water, and we use a straw that has a one-way valve that prevents water from floating out of the pouch while we're not drinking from it. Here's a liquid drink. This is a tropical punch for today. I love drinking fluids on station. Here on station, we have a pretty cool food preparation area. We have a place to get fresh water for us to drink or to put in our rehydratable foods. And we also have an oven to put food in. We pick out some of our favorite foods, chicken fajita for me. Put it in the oven. Close the door and turn it on. In about 15 minutes, I'm gonna have a warm meal. Thanks for exploring a little nutrition with me. I'm going to send you back to Earth so you can create your very own astronaut menus. See you again soon.
The International Space Station is a platform for science about the Earth, but it also hosts science and technology research that's benefiting life on the Earth, while supporting plans for future exploration far, far away from Earth. Those future deep space missions that'll carry human explorers will have to support those people, among other things, with clean water. The station research in that area has had achievements that are already paying off on orbit, and have led to an inexpensive, easy-to-use tool that allows people on the planet to check the purity of their water.
Most of the children, they come here with waterborne disease.
So many children under 5 suffer from diarrhea.
They're complaining about the abdominal pain, skin rashes.
They get waterborne illness through drinking water.
Most of the community members had little knowledge regarding the use of safe water and what safe water is.
Because most of the water we use it without knowing it is affected with disease or not.
So we need to test them so that we make sure that the water is safe or not safe.
A lot of people have the idea that water quality is too hard to do in the field and it's too complicated.
Having to transport samples, having to have reliable electricity, having to heat samples or keep samples at certain temperatures or put them in refrigerators.
But probably the biggest challenge is actually the cost.
The price was really high, up to $300 a test.
So all those things come together to make it really difficult to use a traditional laboratory approach when you're testing water. What's been missing is the really simple, cheap test kit, and that solution came from above. On the space station, we recycle almost all of the water that the astronauts drink, and that constitutes a risk because if that water became contaminated, the astronauts would have to abandon the space station in the worst-case scenario. What we needed on the space station was something that was small, easy to transport, and didn't require a lot of training for the astronauts. We developed a water test kit that was really easy to use and used off-the-shelf components, and we called that the Microbial Water Analysis Kit, or MWAC. It's basically a bag that changes color in it, and the astronauts just had to hook it up to the water system, take the sample, store it overnight, and read it the next day. It worked great, and it's still in use today. This was when we realized we had a chance to make a difference in the world using the same technology that was used by NASA, but applied in a remote area of a developing country.
We started MWater for the biggest health crisis on the planet, which is a lack of safe water. The test kit is revolutionary because of its cost. It lowers the cost of testing water points from hundreds of dollars to about $5 to $7. It can be done on-site in the remote region, and it can give you a result within 24 hours.
I take a sample today, tomorrow I have results. To use a water kit is very easier.
But we learned that testing water by itself wasn't enough. With the mobile app, people could map water sources and record the data.
So that way we're building sort of a global database of water information that everybody can contribute to and share with others.
So what that meant was people who before didn't have a feasible and affordable way to test water suddenly had the means to know which water sources around them were safe.
It's made people much more aware of the issues of water quality. That's a very powerful thing.
And that's all due to technology that we've borrowed from the International Space Station. So now we're able to assemble a really low-cost water quality test kit to ship all over the world.
We've been working with the local health ministry and the water utility in Mwanza, Tanzania since 2013.
Through that technology, most of the citizens in Mwanza have an increased awareness regarding the kind of water they use and whether it causes them any waterborne illnesses or not.
People are now treating their water and avoiding sources of water which could be contaminated. I've seen a growing awareness.
It is very unusual for technology that is used in international space stations to be used in developing countries like Tanzania, but it can be used, and it should be used because this technology is not limited to only developed countries, but for all humankind.
If you want to get another look at any of the stories that we featured today, check us out on YouTube and Facebook. And while you're there at either of these addresses, take a look around because there's a lot of other cool stuff there that you'll find about NASA and America's human spaceflight program. And while you're out there on the internet, be careful. Check out Houston We Have a Podcast. It's folks here at NASA talking about their work in all aspects of space exploration. We post new episodes on Fridays. Today, just a day after NASA's Day of Remembrance, we listened to a very interesting discussion in which Apollo astronauts, engineers, and flight directors discussed the causes of the Apollo 1 fire that took the lives of Gus Grissom, Ed White, and Roger Chaffee. Go to nasa.gov/podcasts. You can find today's episode, in fact, all of the Houston We Have a Podcast episodes, and, yes, there's more, the full library of all NASA podcasts. You can also listen to all of them on Apple Podcasts, Google Podcasts, and on SoundCloud. This is Mission Control, Houston.